Hey, for our first project today, we're joined with.
Ollie Riddell and Ben White.
I'm Ben White.
So, tell us about your project.
We made biodegradable plastic because, in our world, plastic is just a terrible problem. There's a lot of pollution in the world. It takes 500, I think on average, it takes 500 years for plastic to break down, and yeah. So, we're trying to make biodegradable plastic that is as capable as normal plastic, but also breaks down in ample time so that it doesn't pollute our oceans.
So, what do you guys find?
So, what we found was that first we hypothesized we were using sugar, water, vinegar, and cornstarch to make this biodegradable plastic. But what we found in our hypothesis was that more sugar would result in a stronger plastic. But what we found was that our hypothesis was not right, and you need to have a proportional amount of sugar to the other substances inside of the plastic. This is because of polymerization, where you need to have certain amounts of monomers to actually have a solid bond. And when you had too much sugar, or not enough sugar, with not enough, it was too soft. It was too much, it was brittle.
All right, so our results, we found that obviously, like Ben said, that too much resulted in brittle plastic and too little soft. And our results were that 1/2 tablespoon of sugar resulted in being 5.61 kgs to rip apart. And then 2 tablespoons of sugar is 4.8 kgs, which is the worst plastic that we made. And then 1 tablespoon of sugar, which was the correct proportion, came out to be the strongest at 7.9. So it's clearly the best way to make it, and it's actually pretty good compared to normal plastic. Like, it's a little brittle, but yeah. I think we're good. Thank you.
All right, well, stay tuned for our next interview. For our next interview, we're joined with.
Valentine Park and Maxine Minster.
So, tell us about your project a little bit.
All right, so our project is about citric acid and it's about water displacement. And we were measuring, what were we measuring again?
Oh, gas output.
Yeah, gas output with different, varying temperatures, and talking about how citric acid affects plumbing and how it affects your skin and bath bombs and stuff like that.
And what were some difficulties you guys had?
So we had a lot of trials. Overall, we had 9 trials, and throughout the thing, we had a lot of problems with not always having the right amount of water. So sometimes we would lose a few millimeters, and our temperatures weren't always as correct as we wanted them to be. So it was just a bit of some calculation errors.
So, thank you guys for the interview, and stay tuned for the next one. For our next interview, we're joined with.
Olivia Quagrello. Cecilia Tripp.
So, tell us about your project.
Yeah, so we were testing to find the highest voltage in a citrus fruit. We used the metals zinc, copper, magnesium, lead, and iron. So the way we did that was we would take our 2 metals and one metal, rewind a little bit. We started off by calculating these numbers to find which pairing would have the highest voltage. Through those calculations, we found that copper as the cathode and magnesium as the anode would find the highest voltage. So that was our hypothesis, and we were using a lemon because the citrus acid in it acts as a salt bridge for our 2 metals. And okay, so the way we did that, we would stick one metal in. So we'd stick one metal in, so copper, and we'd stick another one magnesium or zinc in, and we would put the 2 different alligator clips on. And when it's in the lemon, just like this picture here, and we'd turn this on and just find the voltage. If the voltage was negative, we knew that the cathode and anode were swapped, so we would have to switch around the 2 alligator clips. And then we would find the correct cathode and anode. So then we did 3 trials of trying all the different possible combinations, and through those trials we found that our hypothesis was correct, that copper and magnesium produce the highest voltage. Some errors in our testing, we found that because we were using lemons, not all the electricity could flow through freely, so our numbers weren't as high as what we predicted, but we still found that our hypothesis was correct. For example, our calculations predicted that copper and magnesium would produce 2.707 voltage, and in one of our trials it produced 1.905. So for this type of experiment, that's pretty accurate, but not exactly what we wanted. But it's definitely still our hypothesis.
So stay tuned for our next interview. So we're here joined with Mr. Jiva, the chemistry honors teacher. So what do you see all these projects here? How many?
We have about 45 projects.
So they've been working since what? Since around November?
So normally we start working on the project in October. So kids go to library to choose a topic, and then they write a proposal. And then from proposal, they come up with variables, and they start coming up with their own procedures. So everything is what they do, so it's independent.
All independent. So what could you say? You happy with the projects came out? They look good from what we've seen so far.
Kids put a lot of effort, so I had to reject many times some of the proposals or the topics. Some of the posters needed to go home to be improved, but it came up very well. I think kids are really excited about presenting and being here, and that's great.
All right, thank you for joining us. Thank you for having us. We'll go to the next interview. So we're joined with
Daniel.
And Paulo.
So tell us about your guys' projects.
So our project is finding oil displacement. So we are trying to find which oil is best used in the kitchen. And the way we try to find that is which oil burns the slowest and the least. So to do that, we find the displacement rate of our different types of oils here. And our hypothesis was, since density affects displacement rate, the higher density, the lower displacement rate would be.
Okay. Essentially, both of our experiments had the cooking oils had a composition of 3 fats. And what happens is you have triglycerides, which are the most common thing in our body. You have phospholipids, which is a group of polar lipids, and they act as a barrier against harmful aspects. And you have the last one being phytosterols, which are commonly found in plants.
So, do you want to hold it? Okay. So for our materials, we have all our oils, and then Bunsen burners and things to do our procedure, which we have here. So essentially a procedure is we have 5 milliliters of certain oil in the graduated cylinder over a Bunsen burner, which is connected to a udiometer filled with water. And then one person measures the amount of oil while the other person stops every 20 seconds. So we did this procedure 3 times, trial 1 with the graph of each displacement rate for each oil in the table. This is for trial 2, and this is for trial 3, and this here is the results. So this is our average displacement rate for each oil, and this table goes with this graph, which shows each oil.
After our 3 trials and testing it on both our 6 oils, then we decided our hypothesis was correct, and it had an inverse relationship. So you had high density, low displacement rate, and so forth.
So there's some ways where you had errors. For example, since oil is very viscous, measuring the right amount of oil could be difficult because we might not get it all out of the graduated cylinder. And delays from stopping the stopwatch at the right time and measuring the right amount of gas could be also produce some error.
All right, thank you guys for the interview. Stay tuned for our next one. So we're joined with
Simon Ramos.
And Simon, what did you do with your project?
I dyed fabrics with Kool-Aid to see which one absorbs Red 40 the best.
And what did you find?
Nylon absorbs Red 40 the best, and polyester absorbs it the worst.
And when you did the experiments, what were some of the difficulties that you had?
I worked alone, and it was hard to time coordinate everything because I had to pour out all the Kool-Aid at the same time, which was kind of a struggle to keep results accurate.
But we'll give you credit. Most projects here having 2 people work on it. Job well done for being the only one that worked on it. So
Thank you.
Stay tuned for the next interview. So we're joined with
Holden Hersey and Elias Cobbett.
And tell us about your guys' project.
All right, so we decided to make rocket fuel with 2 different components. We have a sugar. We use sorbitol for that sugar. We have Fundip over here to show that this can be used to make rocket fuel too, because it's very similar to what we use. And this is one of the oxidizers we use to combine with that fuel to make the rocket fuel itself. We use 3 different ones. We use calcium, which is what this is. We used sodium and potassium. And what we found is the calcium nitrate did not perform very well, and we found that the potassium nitrate performed very well to create rocket fuel. So we combined them in a 35% to 65%, right? Yes. Ratio to make the fuel. And we burned it in a test tube. Here's a little diagram of it to show what we burned it in. And we measured the amount of thrust they created, basically.
So any difficulties with your project?
Difficulties, yes. The first difficulty we encountered was safely doing this, as we accidentally had a mishap with our first batch, which was too big, and it got to too high of a temperature and combusted right in front of me.
Well, we prioritize safety first at the school, but
Yep. We improved our safety and we changed our design and we did it safely after that.
all right. So thank you guys for the interview. We'll stay tuned for the next one.
Okay, so me and Veronica did Red Dye 40, the color for controversy, and our purpose was to determine the amount of Red Dye 40 in drinks and see if it is over the legal amount. And we did it in Gatorade, Powerade, and Coca-Cola. So the average amount of Red Dye 40 that should be intaked is 3.2 milligrams per kilogram of body weight. So someone who's about 70 grams, which is 154 pounds, should have about 224 of Red Dye 40. So we use the color wheel for our wavelength. So obviously you do the opposite to cancel it out. So we had red, so we used green.
We use green as a wavelength because it's a primary color that controverses with red. We first developed the standard curve, which is the absorbance and the concentration of plain Red Dye 40 and water. That was to determine the dilutions that we needed to help us develop the dilutions for the other drinks. We had to dilute Powerade and Gatorade because they both exceeded the amount the spectrophotometer could handle. So we had to dilute it with 30% water and 10% of the drink. And we developed that they each absorbed, the spectrophotometer absorbed a lot more color from them than we did for the water.
So through that, we determined, after doing all the math, which we used Beer's Law, we determined that each drink contained over the legal amount. So Gatorade alone contained 1,831% more than the legal amount. And Red Dye 40 is banned in 22 states already. The FDA is fighting it everywhere, basically. And, you know, Red Dye 40, it can give you cancer, it can give you ADHD, it can give you depression. So when you're, like, especially little kids, when they're like, oh, I want the colorful drinks, I want all the colorful foods, when the parents give them that, little did they know they're giving them early on ADHD, depression, and maybe cancer later on in their life, which is awful because there's no cure for most of those things. So, yeah.
The Beer's Law relates the attention of the light to properties of the material through the light is traveling. This page takes a brief look at Beer's Law Lambert and explains the terms of absorbance and the molar absorbity relating to the UV visible absorbity spectrometry, which is what the main one of the main equations we use, in addition to the molarity, which is mole solute slash divided by V in the volume in L of solutions, liters of solution, and the dilution formula, which is M1 times V1 equals M2 times V2. And our main equation that we used to develop all our dilutions was A equals 45014 times X plus 3.3 E minus 0.03. And that is it.
For our next interview, we're joined with,
Callie. Lila.
and you guys want to tell us about your project?
Yeah, so basically our project, we made 3 different yogurts. Each one we heated the milk to a different temperature, and the point of it was to see like when you're making it how it affects the different textures of it and stuff. And do you want to explain like how we made the yogurt?
So basically we heated 1 to 120 degrees, 1 to 180, and 1 to 220. And by doing that we found that at the 120 protein was not able to form, so it's super runny. Yeah. And then the 180 it was like able to form a little bit, so it's like a little thicker. And then 220 it was like fully formed and like really thick. So we found that the
higher temperature causes a thicker yogurt. So thank you.
Thanks, guys. We're joined with
Gabe Haven.
And Gabe, tell us about your project a little bit.
So this is mummified apples, and I went with the theme of ancient Egypt because mummies, obviously. So my project, the purpose or the question was which type of substance absorbs the moisture from the body tissue and mummifies the best. So what I tried to do is see what preservative out of baking soda, salts, and washing soda would absorb the moisture from the body tissue the best. And my hypothesis was what was the reason for organisms decaying so quickly, and I thought it was water, which I was correct through the process of osmosis, and it created enzymes in the body tissue which would increase like fungal contamination. So my project was to get rid of that moisture, and out of all these four, the baking soda worked the best. So as you can see, it's the most intact out of all of them with the least amount of mold. So these are my data tables. And then the most important aspect of this experiment was to find the lowest weight possible for each apple. And by doing that, I would see how much moisture was gotten rid of for the apple.
All right. Well, thanks for the interview. Make sure to stay tuned for the next one.
My name's Will Ficken. I'm here with Luke Michigan. Luke, tell me about your project.
So essentially, I made 2 filters to compare to 2 professional filters, one a sediment filter and one a distillation filter. The one that proved the most effective was the sediment filter, as it was the most cost effective and it took the least time amount to do it.
Luke, I have a quick question. If you couldn't afford that, like what would be the second best option?
I promise you can afford this. This costs a recycled water bottle, some rocks, some sand, and some charcoal. Anyway.
Stupid question, sorry.
Anyway, so to make this sediment filter, I used rocks, sand, charcoal, and cotton balls. The big filtration part of it was the charcoal, as it had large pores that trapped large materials, such as the algae contaminant. In reality, I would not use this filter for everyday use, as it should only be used for emergencies, as the filter can't filter out the bacteria. In relation to the distillation system, I used a large bowl, a smaller bowl, and rocks and plastic wrap. The idea was the algae contaminant under it would evaporate, condensate on the plastic wrap, and drip out into the bowl. In reality, it was not very effective, as I lost a lot of water due to evaporation, or it dripped back into the bowl. So I only got a little bit of water in reserve. But overall, the filtration part was pretty good and had almost identical results to the distillation system.
So for our next interview, we're joined with
Jason Mail.
Take Semby.
So tell us about your guys' project.
So we did saponification, which is the process of making soap. So for our thing, we were seeing which oil would create the most bubbles when mixed with water. So vegetable oil, olive oil, and coconut oil were the oils we used.
So our hypothesis was coconut oil will react best with sodium hydroxide and produce the most bubbles. That hypothesis was correct. If you can see in our results, coconut oil had the largest difference. No. Take it back.
Coconut oil had an average of 52.3 milliliters of bubbles created, and that was almost double the amount of bubbles created from the other oils. So this goes back to our chemical formula, which is that the triglyceride, or the oil, when mixed with sodium hydroxide, creates glycerol and soap. So coconut oil was the best triglyceride out of all of the oils.
Thank you guys for the interview. It looks great. Well, stay tuned for the next one. So we're joined with
Sam Morse.
Caleb Riley.
And tell us about your guys' project.
Caleb, you can start us off. So, a lot of countries around the world don't have a stable source of drinking water. and many countries have a large source of seawater, but you can't drink seawater. So our big question was the best way to remove the the salt from the seawater. So how many times does seawater need to be distilled to make it drinkable?
Because distillation is the best method that we could do.
Yeah. So we did titration to see the concentration of salt in the water, and we ended up distilling it 3 times.
So essentially the titration, long tube, big cup, you drip silver nitrate, which we knew the concentration of, into the salt water, which we did not know the concentration of. So you do that until a reddish brown substance occurs, meaning the reaction happened. Once that happens, you record it, plug it into a big math equation, and we have the concentration right here. Do you want to get that? Yeah. 12.384 grams per liter of salt when you don't distill it. So we distilled it once, put the water in, Bunsen burner, evaporate it, condensate. We have water. One time distilled, it drops all the way from that to that, which is like, a
huge amount.
Pretty big jump. But it's still not safe to drink because the New York Department of Health says that you need it needs to be under 20 milligrams per liter to be safe to drink. And this is
not that.
It's 27. Oh wait, no, it's 272.
Yeah, 272.
So we did it again. This one's 59, which is closer, but not enough. And then after 3 times, it's 14.2 milligrams per liter, making it safe to drink according to the New York Department of Health.
Well, thank you guys for the interview, and stay tuned for the next one.
Forbes and Oliver West.
So tell us about your guys' project.
So we did Alka-Seltzer gas displacement. We were trying to see what type of liquid would be best for getting gas out of your stomach as fast as possible to get the best benefit.
And what did you guys find?
We found out that the higher acidity liquids dissolved the Alka-Seltzer the fastest and produced the lowest amount of gas. So therefore, higher acidity things are better for receiving the benefits from Alka-Seltzer.
All right. Well, thank you guys for the interview, and stay tuned for the next. And for our next interview, we're joined with.
I'm Anthony Colella, and that's Draco Corrado. And our presentation is to find the iron concentration of specific vegetables. We chose to do this project due to the amount of people who suffer from iron deficiency in the U.S. alone. And I at least know my mom has low iron, and many people I bet, have iron deficiency or may suffer from low iron. So we actually tested 3 different types of vegetables. We tested broccoli, peas, and kale to find the concentration of iron. And in prior research, we did find out that one of these tended to have higher iron concentration due to its high elevation that it grew in and the iron-rich soil. Draco?
And so we hypothesized that the kale would have the highest iron concentration. And so to conform our results, we used a method called oxidation reduction titration, which involved us acquiring 50 milliliters of potassium permanganate and then our 25 milliliters of vegetable solution and sulfuric acid. And then we titrated it until it turned from this green color to a light pink color. And then we took however much potassium permanganate it used, we put them into these calculations to find the amount of iron per gram of vegetable.
Using these equations, we found that kale was in fact the highest concentration of iron per gram at approximately 2%, while the other 2 vegetables, peas and broccoli, had approximately 1% iron. And we found that this would be great to add to your diet, and we just think that in general it can help people who might have iron deficiency because in larger samples it could be very positive.
All right. Well, thank you guys for the interview, and stay tuned for the next one. So for our next interview, we're joined.
I'm Saskia.
I'm Alex.
And you guys want to tell us about your project?
Yeah, so basically our project was on how to remove microplastics from water and using a ferrofluid and a magnet. So ferrofluid is a mixture of iron and oil, and we put it in the water and then used a strong magnet to remove both the iron, the oil, and the plastics that were bonded to the mixture.
Yeah. We found that HDPE was easiest to remove from the water. We removed 60% of it from the water. And then we found that EPS and PET didn't really get removed as well as HDPE. HDPE is like a plastic milk jug, and then PET and EPS. PET is like a Polar Springs water bottle, and then EPS is styrofoam. So,
We actually don't have any milk cartons.
yeah.
Thank you guys for the interview, and make sure to stay tuned for the next one. So for our next interview, we're joined with
Arvi.
Nate. And tell us about your guys' project.
We did measuring the amount of acetic acid in different types of vinegar. The purpose of this experiment is to find out which vinegar is the most acidic because you can use it for cleaning or cooking. Our hypothesis was that white vinegar is going to be more acidic because it's made by fermenting grain alcohol. We did this by using the process of titration. Titration is a technique used to determine the concentration of reacting with a solution known as the titrant. As you can see on the picture, we filled the beaker with distilled water, white vinegar, and phenolphthalein, which is an indicator. In titration, the indicators are special substances that change color when the pH of the solution changes, indicator helps us see when the titrant, which in the solution known as concentrated, is completely neutralized, and analyze the solution of an unknown concentration. We use phenolphthalein for ours because it's clear, and you can see the color purple, like when it changes colors, right, as you can see on the picture. We did the procedures. We measured 5 milliliters of vinegar using a pipette or a graduated cylinder and transferred it to the flask. We added 20 milliliters of distilled water. This dilutes the vinegar, making the color change, and the end point is easy to see. The pink color will disappear as you swirl, but as you continue to add sodium hydroxide, the color pink will stay permanent and it will not change colors.
Well, thank you guys for the interview. Make sure to stay tuned for the next one. For our next interview, we're joining with
Raphael Tesaweek, Jack Smith.
And you guys want to tell us about your project?
Yeah, so our project is about electrolysis, which is a way of separating water into its two main components of hydrogen and oxygen. And the way we do that is by using electricity and an electrolyte like salt, which will allow the ions in the water to move and separate into hydrogen and oxygen at 2 different points. And our project was to determine if the amount of sodium fluoride, which is our electrolyte, will affect how much hydrogen and oxygen is produced in under 10 minutes. And we learned that by adding more, it will produce more hydrogen and oxygen, but it will get to a point where there's too much sodium fluoride for the small amount of water, so it won't go up anymore, and it'll just stay the same.
Thank you guys for the interview, and make sure to stay tuned for the next one.
All right, hello guys. Okay, so our project, all right, I'm not doing this, you're very disrespectful. Okay, so this is about evaluating the effectiveness of different types of toothpaste with different ingredient bases in protecting your teeth against acid erosion. And acid erosion is caused by a lot of things, but we were focusing on, he's laughing, it's not funny, this is serious. So, but we focused on citrusy foods and sugary drinks. So we use vinegar as a model, and we use eggshells because of their similar structure when calcium has teeth. And so, Elle, do you want to explain this part?
Okay. Yeah, so we used a reaction. We put the crushed eggshells in a reaction container. Oh yeah, so we took eggshells and we coated them in the 3 different types of toothpaste, and we also had a control egg, and then we crushed them up, and we
put them in the reaction container, and then we poured vinegar over them and mixed them for 5 minutes. And every 30 seconds, we measured the amount of carbon dioxide produced from the experiment. And also that we measured the pH balance of all the liquids after, and the higher the pH, the less erosion that occurred.
Okay, so I don't know if she just talked about this, but basically, these are our tables, and this is more visually, like it's more easy to understand because this is only the one trial per each group. Aiden, oh my. And then this is each 3 trials for every group. And so you can see with the control egg with no toothpaste on it, it lost 65.8 milliliters of carbon dioxide, which means the least protection against acid erosion. And then the one with the fluoride toothpaste that we predicted would have the best protection lost 35 milliliters only. So almost double the amount of carbon dioxide lost. So you should definitely use Crest. I'm gonna wrap this up because Aiden is huffing and puffing over there, so that's it.
So for our next interview, we're joined with
Samantha Damati.
And you want to tell us about your project a little bit?
Yeah, sure. So my project is called Microwaves and Meltdowns, and it's basically about can you accurately measure the speed of light using a microwave? And I found out, yes, you could accurately measure the speed of light using a microwave by basically only using a microwave, a plate, and removing the revolving door out of the microwave, 3 chocolate bars, and a ruler. Basically, in order to find the speed of light, you put the chocolate bar on the plate in the microwave it for about 15-ish seconds, and since there's no revolving plate, it'll melt unevenly and there'll be certain hot spots in the chocolate. So you can measure the distance between the 2 closest hot spots, and that'll get you half the wavelength of the actual waves of the microwaves. And you times that by the frequency of the microwave, which you can find on either the back or the side of the microwave, and that'll get you a speed of light. So I did 3 trials, and I calculated an average speed of light of 2.94 times 10 to the 8th meters per second, which is pretty close to the actual speed of light, which is 3 times 10 to the 8th meters per second. So.
Thank you for the interview, and make sure to stay tuned for the next one. So for our next interview, we're joined with
Sophia. Ezra.
And you guys want to tell us about your project a little bit?
All right, so we were testing the effect of colored lenses on the ability to perceive color. So we had people walk into a room with no natural light and try on each pair of glasses and then identify what color different markers were, and we saw how accurate they were.
So for our hypothesis, we thought that the red glasses and the violet glasses would be the most difficult to accurately perceive color with, since they're at either end of the visible light spectrum. However, we were right about the red glasses, but the violet glasses were actually the 3rd most difficult, with orange being in 2nd. And then the yellow and green glasses were the easiest to see. They both had 100% accuracy.
Thank you guys for the interview, and make sure to stay tuned for the next one. So for our last interview, we're joined with
Aaliyah.
Kira.
And if you guys want to tell us about your project?
Sure, so our project was crystallization, and we tested the solubility of salt and sugar in different temperatures of water to see which would produce the most supersaturated solution that would result in the largest crystals formed.
Yeah, our hypothesis was ultimately proven, and we found that with the temperatures that we tested that the salt created the biggest crystals, but sugar at a higher temperature creates bigger crystals.
And then tying it back into the modern world, you can use crystallization treatment to treat wastewater, and it's actually more effective than regular wastewater treatment, half of the price and operational costs, and it is better for the environment. So it removes the salt from the wastewater and the impurities, making clean water, which would be really needed right now in our world because we have 1.8 billion people every day drinking dirty water. So this would greatly improve clean water in our ecosystem, and it would be better for the environment and everyone. Yeah.
Thank you guys for the interview. Thank you guys for watching. Hopefully you guys learned something new, and make sure to subscribe, like, and turn on notifications so you never miss another video. Thanks, guys.